Okay, in this problem we have two blocks, two meshes which are connected by a string, and one is 2 kilograms, the other is 4 kilograms. The 4 kilograms block is also pulled by an external force F, and we have also friction forces acting on the blocks, and the block surfaces and the ground surface has this coefficient of frictions, static coefficient of friction of 0.3 and the kinetic coefficient of friction of 0.2. So the first part of the question is, what is the maximum force F that can be applied to the system if the system is to stay at rest? And you see, I mean, if you have a very large force, external force acting on these blocks, even if there are frictional forces, the system as a whole will start to move toward right. But if this force is below a critical value of maximum force, and because of the frictional forces, the system will stay at rest, because the force, external force, will not be larger than the total frictional force, static frictional force between the surfaces of blocks and the ground. So for this first part, let's imagine that we have these two blocks as one system, because the frictional coefficients between the blocks and the ground is the same for both blocks, and we know that the frictional force, the force of friction, is proportional to the normal contact force between the surfaces and also the coefficient of friction. So in general, the frictional force is the frictional coefficient of friction times the contact force between two surfaces. And these contact forces between the surfaces are always normal to the surface. This is the principle behind calculating the frictional forces. So let's start by writing down the Newton's second law for the system as a whole. And the thing is, let's take the toward right, the positive x-axis as the increasing x direction to the right. So the total forces acting on the system must be equal to 0, because we claim that the system stays at rest. In that case, let's try to write down the total force. First one is the external applied force F, and we want that F is maximum, and of course the frictional forces acting on the blocks. Let's show the frictional forces on each block by drawing the free body diagrams. The first thing is the block, the 2 kilogram block is to be pulled by this tension, and of course there will be frictional force which is in the opposite direction. The frictional forces are always opposite to the external forces, applied forces, or if it is in motion, they are always opposite to the direction of the motion. And of course there are this is the weight, and let's write down the numerical value. 2g is the weight of the block, which is downward, and the normal contact force between the second 2 kilogram block and the surface, let's call this n1. So this frictional force is the static frictional force, will be n1 times the coefficient of friction, mu s. In this case, we use the coefficient of friction as the mu s, static coefficient of friction, because the system stays at rest. If the system will be in motion, then in that case we will use the kinetic coefficient of friction, which is mu k, and there is always a difference between these. There is always two kinds of coefficient of friction. One is called static coefficient of friction, and it is usually denoted by mu s, and the other is the kinetic coefficient of friction. It is always denoted by mu k, and as always mu s is larger than mu k. Okay, so well, the system has then in that case two frictional forces. One is acting on the 2 kilograms block, and the other is acting on the 4 kilogram block. And if you draw the free body diagram, let's call this the first frictional force as F1, and the second frictional force acting on the 4 kilogram body as F2. And this also has a contact force, and also it has a weight for G, and this force is the external force. Okay, so if we call the system as a whole, then we can, well, we have also this tension force T for the 4 kilogram body. If we take these two blocks as one system only, then we can ignore the tension T, because tension T is acting toward right on the 2 kilogram block, but on 4 kilogram block it's acting toward left, so these tension forces will cancel each other if you look at the system as a whole. So there are only frictional forces, and they are in the opposite direction, F1 minus F2, and this will be equal to total mass of the system, which is 6 kilogram times, of course, A, but since the system is to stay at rest, this is equal to 0. So the maximum force applied to the system, if the system will stay at rest, then in that case will be equal to the sum of frictional forces acting on each body, each blocks, 2 kilogram and 4 kilogram blocks, F1 plus F2. And for the first frictional force, it is mu s times N1, and the second one is mu s times N2. Well, mu s times N1 is just the normal force between the 2 kilogram block and the surface, and it's just 2 times G, and the second normal force is just 4 times G, so this is equal to mu s 6 G. So the maximum force in that case to be calculated, mu s 0.3 times 6 times 9.8. So if you calculate what this is, then let's use my calculator. 0.3 times 6 times 9.8, and this is equal to 17.6 newtons. So if the external force applied acting on the system is less than this value, 17.6 newtons, then the system will stay at rest, because this force will be less than the frictional force acting on these two blocks. But if the external force is larger than this 17.6 newtons, then since it will be larger, this external force will be larger than the static frictional force, then in that case the system will start to move toward right with certain acceleration. Okay, before that, let's continue to solve part A by also finding the tension between these two masses. But to find the tension, then we can only concentrate on one of the bodies. Let's concentrate on 2 kilograms. If the system is stays at rest, then 2 kilogram bodies also stay at rest. In that case, if you want to write down the Newton's second law for the 2 kilogram body, and in that case you will have the forces acting on 2 kilogram body is equal to 0. Well, let's write down explicitly what these forces on 3 kilogram body. tension toward right, and minus, of course, the frictional force on the 2 kilogram body, and this is equal to 0. Sorry, let's erase this. And from this equation you will easily find that tension will be equal to the first frictional force, the frictional force acting on the 2 kilogram body. So it's nothing but mu s times 2g, and mu s is 0.3 times 2 times 9.8. So this can be calculated by just using the calculator, and I'm leaving it to you. So in the second part, and this was the first part, in the second part, if the external force F is twice this maximum force, 17.6, what will be the acceleration? Because as we have already said, if the external force is larger than this, then the system will move toward right with certain acceleration. And let's find this acceleration then. So in that case, again, we can see the whole system as one body of 6 kilogram, and let's write down the Newton's second law in that case in the x direction, and the total forces will be equal to the total mass times A, and the total mass is 6 kilograms. So let's write down these forces then. External force is 2 times F max minus the frictional forces, but the frictional forces to be calculated this time by using the coefficient of kinetic friction, okay? Because the system is in motion. Whenever the masses are in motion, then in that case the frictional forces are to be calculated by using the coefficient of kinetic friction. The only difference is just you will replace in the first part, you will replace mu s by mu k. So the total frictional force, in that case, let's write this 2 times 17.6 minus, and mu s, instead of mu s, we write mu k, which is 0.2 times 6 total mass times g. So in this equation, the only unknown is A, and A is equal to 2 times 17.6 minus 0.2 times 6 times g, and this is to be divided by the total mass, and total mass is 6. So this is the acceleration if you apply the external force, which is twice of this critical value. And the next is, in this case, what will be the tension? And the tension, for the tension, again, we can simply use the Newton's second law for the 2 kilogram body, and let's write this T minus the force of friction on the 2 kilogram body will be equal to 2 times A. A is already found from the first part, and if the frictional force on the 2 kilogram body is nothing but, let's write this explicitly, 2A plus the frictional force, and 2A times mu k times 2 kilogram times g. And let's write these explicit, 2A plus 0.2 times 2 times 9.8. So A is already found from the this part, and we already know all the numerical values. The only left is just plug and check these numbers in your calculator to find T. So this completes our solution.